In your science notebook, in the table of contents, you're going to write conservation of matter. Conservation of matter. ... Page 56. On page 56, you need to write down your page number wherever you're keeping up with your page numbers and glue down this page. You will answer the questions on this page as you continue to watch the video. In our science lab today, we are going to be talking about conservation of matter. Conservation of matter is just that. Matter is conserved. It is neither created nor destroyed. And we're going to prove that today in our lab. So what I have here are some Legos. So the first part on page 56 says how many bricks were used, the separate pieces. Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 separate bricks. So you need to write that down on how many bricks were used for separate pieces. What was the weight of the bricks? And, well, it says draw the bricks. You can also draw what the bricks look like. What is the weight of the bricks? To do that, we are going to use this triple beam balance. So I'm going to take all 15 bricks and put it on this triple beam balance. I purposefully chose to use the triple beam balance because I bet a lot of you have never seen one before. So what we're trying to do is we're trying to turn it this way. We're trying to make this balance level. Right now it's not level because this line is way up here. So if I move, we always start with the biggest one first. If I move this over to 100, that's too heavy. I'm going to back it up. I'm going to move this one that goes by tens. I'm going to move it over a 10. Didn't move. Over to 20. Didn't move. Over to 30. Ooh, too heavy. I'm going to back it up to 20. Where's my 20? There's my 20. Now I'm going to go by ones. There's 21. 22. 23. 24. It's still not moving. Ooh, ooh, ooh. 26. It's got some movement to it. That's a little bit too heavy. I'm a little bit over 26. Let's back it up a little. We want this line to be directly in line here. So that is pretty much it. So that is going to be 26 grams is what you're going to write down for how much the separate bricks weighed. So the first section of your chart should be filled in. The separate pieces, what they look like, how many bricks there were, and the weight. I'm going to fill mine in. There were 15, and they weighed 26 grams. Now, I'm going to take these same 15 pieces, and I'm going to build a structure. So, how many pieces were used? You need to put down 15. Interesting. Okay, I'm going to build a different structure. Let's go this way. Ow. I know my structure is not very creative, but I am building a structure. Ta-da! So, how many bricks were used? 15. What is the weight of the bricks? We're about to find that out. Draw the bricks. So you need to draw what my structure looks like on your paper. You might need to pause the video to get that drawn. We're going to weigh the structure. So we're going to take it, put it on our triple beam balance again, and we need to get it leveled out. So we're going to start with 100. Nope. 10, 20, 30. 30 is too much. Go back to 20. 21, 22, 23, 24, 25. Ooh, it started to move a little bit, but it's not level. Moving a little bit. It's 25 and a half. You can see it is 26 grams. So when I created this structure, when I put these pieces of matter together, I did not create or destroy matter. There were still 26 grams was the mass for the bricks, whether they were separate or whether they were together. Now we're going to look at this also with salt water and with ice and water. For the next part, for the type of beaker I'm using, which is actually a cup, we're going to zero out our triple beam balance. So if I took this off, that would really be zeroed out because it would be level. But I'm going to put this on and I'm going to make it level again. I'm going to start with 100. Nope, not 100. Okay. 10, 20 is too much. 11. That's pretty level. So our cup is 12 grams. We don't need to write that down anywhere. I'm going to take this cup off, okay? And I'm going to put on our beaker of water. So our beaker of water is, let's see. We know our cup is 12, not 112. 20, 30, 40, 50, 60, 70, 80, 90. Interesting. It's not 112, but it's 100 and, whoa. So that is 103.5. So on your notebook where it says what was the weight of the beaker of water, you're going to write 103.5 or 103 and 5/10. All right, we're going to take the cup off. We're going to go back to our 12 that our cup is, or our beaker that we're using. And then we're going to put on a cup of salt. We already know the cup is 12, so it's got to be more than that. So that is about 22 grams. Now, this is important. You're not going to write down 22 grams. Notice it says, what is the weight of the tablespoon of salt? That means we don't want the cup with the tablespoon of salt. We want just the salt. Well, I can't really pour the tablespoon of salt onto here because I'd make a big mess. So we're going to have to subtract the 22 grams, which is both of them, minus the 12 grams, which is just the cup. So 22 minus 12 is 10. So our salt by itself is just 10 grams. We need to write that down on our question. Now we're going to go back to our cup of water. We're going to pour in our cup of salt and weigh it again. Do you have a prediction as to what the new weight will be? I am making a solution because the solute is dissolving in the solvent. That was from our Mixtures and Solutions lab. Yes. So what is the combined weight of the water in the beaker and the salt? Let's go back to 0. We're going to go 100, 200, oh, too much, 110, 120, oh, too much, back to 110, 110, 111, 12, oh, we're getting close, Not quite there, but it is moving. 113. So it looks, there we go, pretty level. And that is at 103 and a half, or 113 and a half, or 113.5. 113.5 grams. You need to write that down for the combined weight. So if you notice, matter was neither created nor destroyed. We took the matter of the water and the salt and we put it together, but matter was conserved. It was all added together. The two totals, 103.5 grams and 10 grams of salt, when we put them together, we got 113.5 grams of combined solution. Even though we can't see all the salt particles that are in here, we just proved that all of those salt particles are still in here. And if we were to evaporate all of this water, how much would the crystals left behind weigh? The crystals left behind would weigh our 10 grams because matter is neither created nor destroyed, it is conserved. All right, we're going to look at the same thing again with ice and water. For the final part of the lab, I have a bag of ice that we are going to get the weight of, and then we are going to wait for it to melt and weigh it again. Now, why do you think I have the bag of ice in, well, why do you think I have the ice in a bag and not just in a cup? Would our experiment be the same if I measured it in a bag and in a cup? No. What happens to the water or the ice when it's in a cup? Some of it is able to escape and evaporate. But in the bag, it is not able to escape and evaporate because the bag is closed. So that is why we're using a bag. So we're going to get the weight of the bag of ice. 100 is too much. 10, 20, 30, 40, 50, 60. Oh, 70 is too much. Go back to 60. Oh, 65 is too much. 64 is too little. So that is 64 and a half, so 64.5 grams. So write that down on notebook page 56. What is the weight of the baggie and ice cubes? And then we will wait for this to melt and see what the weight is after it melts. The ice has now completely melted. You can see it is all nothing but water. So we are going to see what the weight of the water is after the ice has melted. I actually didn't change any of the settings on the triple beam balance. You can see it is still, well, maybe you can't see. Here we go. You can see it's still level at 64.5 grams. So on your notebook page for what is the weight of the baggie and the melted ice cube, you're going to write 64.5 grams. You also need to answer the final question, which says, what do you notice when measuring the different weights in each experiment? So what did you notice about the Legos before and after they were built into a structure? What did you notice about the salt and the water before and after it was combined? What did you notice about the ice before and after it was melted? Make sure you have finished page 56 because it will be part of your notebook grade when you come in on the 17th.